Hi, very happy to see you all here. My name is Artem. I'm a software engineer at day and a physicist at night. Past 8 years, I've been working with different kind of analytics, starting from computational fluid dynamics to business analytics. Today I want to share this story, which is a bit the personal one, but I think you will find something useful for any project you're making, not only the data visualization, but that's something that, yeah, visualization is something that I like. In the end, I'm very easy to inspire person, and yeah, initially I thought that visualization is something that is, well, you just go and you just plot, and that's easy as a piece of cake. But as you might deduce from the title of my talk, it was absolutely not the case. The bumps on the road were many, and I'm here to share some learnings that I learned along the way. So that's how my journey looked like. And when I look back into my journey, I can say that, well, there were many mistakes, but if I try to summarize them, I could definitely say that I didn't know the rules, how to make the good data visualization, what makes data visualization good. I spent too much time on prettifying the graphs without actually adding any value to the stakeholders that I'm creating those graphs. It was a nightmare to version my code because I love Jupyter notebooks. I ended up in a huge directory of various Jupyter notebooks that I cannot manage at some point, and it was a nightmare. I was thinking that it's very hard to break data visualization, so I learned that, okay, it's actually possible. I made a mistake when I had to reprocess all the data when, you know, like all the fire is around and then you just run with a glass of water trying to, well, to stop this fire from, from continuing. I've been in that situation, so yeah, I learned a few things. And yeah, so I had to reproduce the data, and today I'm here to share some learnings that I learned along the way and maybe some practices that could help you to avoid those kind of mistakes. But before we start to talk about the specifics, let's just talk about visualization in general. And as I said, like for me, when someone says like, hey, we have some data, I mean, can you help with visualization? I usually very easy to inspire. I go and I say, yes, of course, let's get it and let's do it. And I have like very colorful images in my head how it should look like. But in reality, what I've learned is that when someone comes to you and says, let's visualize something, you have one thing in your head, but they have completely different thing in their head. And sometimes after spending like hours on working on something, you could end up in a situation when, well, basically what you thought you're making a visualization, the people for who you make a visualization, they have completely different thing in mind. So maybe they even don't any visualization at all. And in my talk, I will show the examples of Matplotlib. I love Matplotlib. I think it's widely used in, well, in data science. But it's not restricted to Matplotlib. You'll find the approach is universal. It's object-oriented approach, and you can apply it to any library you use or you like. And when we talk about visualization, actually, the first question that I ask myself or the stakeholders that want that visualization is what kind of visualization do they need? It can be the static visualization or dynamic visualization. Static is something that people usually put on reports like A4 paper, and they print it like, I don't know, weekly, monthly for their management. Dynamic is the dashboard that requires some action from people. So they go to some website, they can interact with the data, yeah, they can explore something, but that's the two big groups of data that we can think of. But yeah, remember, before coding anything, it's very nice to align on your goals. And the fastest ways to align for me is to try to get sense of data and maybe to draw something. And that actually works well because you can communicate with your partners. Is it something that you need? For example, if you have something running A/B test, maybe you need to see how the sales evolve over the time. Or if you need to compare, for example, two different algorithms between each other, so probably will pick some bar chart and see how it would look like. The key point here is that, yeah, having drawn that on piece of paper can allow you to save some time later. And it's also nice to think about the corner cases. Because, for example, if you visualize how you wrote the awesome algorithm that performs like in nanoseconds, and another algorithm performs in seconds, what you could end up with is just like one huge bar for the poor algorithm and very little bar that is, well, not visible for your nice algorithm. Basically, you miscommunicate the message, so you kind of show that, okay, everything is, okay, slow, but you don't show what is important, your thing that you've been working on. And again, I mean, the best visualization library or tool is the one that you know the most. So it could be Matplotlib or it could be something else. But yeah, I think at that point is enough hypothetical examples, and let's get to code. And that's my favorite part. And when I start any data visualization project, I start very simple. You could notice a few things on the screen. So on a high level, there are two directories. The first one is the .github directory, and the second is the directory for the project we are starting. We will go over each of them. So the PyData Berlin is the directory that contains the data, the plots that I used for this presentation. And the .github folder, it contains the GitHub workflow for CI/CD thing that I will show you why it's important. Because in some time, the visualization project, they tend to become bulky and very unmaintainable. But on a high level, if you structure like that, you'll see the benefits of doing that. And why I like to introduce the continuous visualization or continuous integration into my project is because it can work as a test. And also, what I try to do with my visualization, I want every plot that I create to be reproducible. And for that, I simply like to put all the plots that I ever create to the single file, which I called gallery.pdf. And the continuous integration, it allows me to create this gallery PDF file. And as you can see here, it's the kind of plots that I generate for this presentation. And you can find them on the GitHub workflow attached to the, like, on the bottom. Sometimes it's nice to, well, not to introduce it like as a separate file, but having them in the code, because maybe you'll go and you'll show the GitHub repo. So for that case, I sometimes put some visualization in SVG format to the README file. That also allows me to track, and to showcase what's in what my visualization code is doing. If you remember, the first thing that I said, that I didn't know like what is good and what is bad for data visualization. And in my practice, I usually use a few kind of plots. It's like a chart plot, line plot, bar plot, and tables. And the opening book that I kind of very thankful that I discovered it. It was Roger Scientific Visualization, Python plus Matplotlib. It's a very nice book that teaches you the good design principles. We can name them one by one now. They are self-explanatory, but I really advise you to go after and to check out his book. It's a fantastic one if you use Matplotlib. So basically, the first one is what I've started with. It's like knowing your audience is the key. Then you need to identify the message, adapt figure to support the medium. Captions are not optional. Don't trust the defaults. Use color efficiently. Don't mislead the reader. Avoid chart junk. And message trumps beauty. And the final one is get the right tool. Yeah, all of them, they worth a separate talk. And actually, there are lots of talks around the design principles that you can find online. But for me, the main focus today is on structuring the project. But let's look into action here. So let's consider this example of Roger from his book, How to Make a Good Data Visualization. So he creates a div showing that, okay, some things, they are redundant. They just create a confusion. And if you try to optimize the graph, try to keep in mind the less is more. And that's actually the thing that I always keep in my head when I'm creating the visualization. So in reality, when you try to show as much data as you can, in the end, you may end up not showing anything. And what I like specifically about that example is that, yeah, over time, you see how it evolved from very complex graph to very simple one. And even without knowing the context, oops, it switched. Even without knowing the context, you see how author tries to emphasize that something with bacon is going on. So this is the importance of clearing the message for the audience. Usually the line charts, they are simple, but I don't like the Matplotlib defaults. And usually what I start when I take a new library for data visualization, I start to explore with basic things like that, trying to experiment how visualizations are structured and how I should interact with the framework by repeating this basic chart. So here you can see that, okay, it doesn't look like a default Matplotlib figure. However, there are little tweaks needs to be made. And what you could notice that the title is left aligned, the labels are directly on the plot, the while label is 90 degrees rotated, so we don't need to rotate our hand when we read the y-axis label. Yeah, so that's the first plot I make if I try a new library or something. With Matplotlib, it's quite easy because everything in Python is an object. In Matplotlib, it's not exception. So everything in Python and in Matplotlib is an object. So you can easily modify their state before you call the figure show method. So let's continue. And actually, that's what I showed. That's the first thing that I do with my plots. You could notice a few things here. So I simplified the code a bit, so that's easier to consume. But you could notice that I usually like to use the Python files instead of the Jupyter notebooks. And for any plot that I create, I name them as a plot underscore something. And in this case, it's a plot common chart. And then that's what I said. First, you create the two objects, the figure object and the axis object, and then it's object-oriented approach, so you can easily modify the attributes of your object to get to the state that is presented here. In business domain, I usually see the things that the data is complex. And people tend to use like, okay, on average, we have something X. And I see another value of data visualization, and here it's like the point that it's very hard, like it's very easy to mislead the reader. And I recently found a very nice article that shows that you can get the completely different data sets, but the same statistics. And if you play this GIF here, you see that the data set changes, but the averages and all the statistics, they stay the same. So that's another argument of using the data visualization, is not to mislead the reader. So, and don't mislead yourself. So usually people who requires data visualization, they're busy, and what they need to understand is like, yeah, we need to think how to create the effective visualization, and don't mislead the reader. If you go back to the structure, so now we have a complex, like more complex directory. So it's basically the directory for this presentation. So you could notice a few things. So now I'm showing you this src directory. There are a couple of Python files. Most of them, they start with a plot something. So each of them are executable by itself. So for example, if I want to reproduce the sine function, I just call plot sine, or if cosine, plot cosine. If plot waves, I just run Python plot waves. and it generates me a SVG plot, yeah, it's ready. That approach works well for me. Why? Because once I found myself like in a very difficult situation when I had like tons of Jupyter notebooks where they have like pretty similar names with untitled something, and I usually see people using them. It was a nightmare to find like the plot that I created and to reproduce it. And since then, yeah, I learned that, okay, it's very nice to separate your data from the data visualization. And it also allowed me to structure the project a bit differently and think a bit differently. So for example, if I would recreate a plot like that, if I would do it in a Jupyter notebook, I would probably create the first plot. And then if I would experiment with that, so for example, imagine if I need to change the color scheme, I would copy paste my cell to the new cell, I will change the color scheme, then I will repeat this process for another cell to get the third one. And it's not really scalable. So first you have these endless Jupyter notebooks with many of cells, then you tune one cell. If you want this change to propagate to any other cell, so you have to repeat this process again and again, yeah, it's not a good way to do it. That's how I do it now. So basically, yeah, I have a few functions. So I already talked about the plot underscore and visualize underscore, but you see how easy it is because on the slide, the third function is the main function that generated these 3 plots. So you see that I create, like I read the data lives separately. I create the figure and axis containing of 3 plots, and then I just call the methods. And you can see by this simplifying that, okay, there are also some anti-patterns because, yeah, I call the same function again and again, and then I call the set title. It also allows you to think like how you can simplify your code. Another example is when you need to experiment and yeah, with the data. So data is static, is separate from your data visualization. But sometimes you need to convey the message to your audience. And that way it's quite easy. So on top, it's not misleading graph, but you see all of other 3 are misleadings. And why? Because that's the same data, but different access sizes. And if I would write the article saying that, hey, come on, like the global warming is is crazy, I would use that misleading graph with exponential growth. However, there is no exponential growth. Or maybe if I want to convince people that, okay, the global warming is it doesn't exist, I would use the graph on the bottom. It's the same data, but with the different axis scales, it looks completely different. And when you, yeah, here it's not for visualizing and convincing you that, yeah, there is a global warming or not, but it's mostly for the code that is written on the left. It's the same building blocks that I used before. I used to reproduce this graph. That also brings us to another point. You see here, the data visualization is separate from the data itself. So, and the tests are important. And sometimes you don't know how to write a test for your data, but you at least know something. So you know that, okay, your temperature, it would be a number, it wouldn't be in the string. So you can introduce some basic tests on your data that, yeah, you stay safe. Or for example, if you know that, okay, the temperature of water, it doesn't exceed 100 degrees, maybe it's a nice idea to introduce that test, even if it's doesn't show you much, but in case something fails, for example, your processing start returns nones, you will know that, okay, your test is failing because your data is not integers anymore. So you have this alert way earlier than before. Another thing that I found is that it's very nice to version control the plots this way, because as I said before, for me it was like endless amount of notebooks and I didn't know how to use the version control effectively. But after I split the data processing code with the data visualization code, it's quite easy. And another thing that I really liked is that, okay, here I kind of get the GitHub example, but If you go to Visual Studio Code, you can use a plugin to go back into history, and then if you introduce any plots to your, well, GitHub repository, you can basically open the SVG file and go back in the history, and then you can revert to any commit like in the past, because imagine that someone comes to you and says that you need to change anything. So it would be quite easy with this approach, which is harder with Jupyter notebooks in my practice. Another thing that I found myself not doing at some point, and I'm doing it now, learned by my experience, is that not setting up the health checks. And remember when I said that it's nice to have the gallery.pdf file, it works kind of a test for me, because anytime the data changes, the gallery PDF file will also change. And for example, I can introduce the simple GitHub workflow here that is self-explanatory. So you basically execute the Python code, which is on the bottom. So I call assemble plots.py that assembles all my plot functions and generate the PDF file. And I know that if I change anything in my plot, if any of the plot function fails, the workflow will fail. I will get an email, and I can go and fix it. So I immediately notify that something goes wrong. And I can do it in a pull request. So yeah, before merging to the main, I already know that. And that's, for example, how my assemble how do you call it? Assemble plots file looks like. So it may look complex, but it's not. But the key is on the line for file in path, parent glob plot underscore py. So what it does, it reads all the plot underscore Python files on your directory, and it imports all methods that starts with plot underscore, and it executes them. It executes them and adds the plot to gallery.pdf. So that's why in a big project, I found it very useful to have this gallery.pdf file where you can just go and showcase to people. You might think of that, okay, I'm not coding, so we have a static environment like Tableau, Grafana. Here I also learned some lessons, and I made some changes to production dashboard that actually are not supposed to be there. And from my experience now, I always keep 2 instances of the production dashboard. So I have my staging dashboard and I have my production dashboard. And before introducing any change in data or in visualization and prod dashboard, I do it in staging environment, communicate with the stakeholders. If they are fine, I push the changes to prod. Knowing the limits, it's mostly about the data processing algorithms that you use. Because sometimes you write the test and it works for your specific case, but maybe if you increase the data like thousands of times, it will stop working. Or maybe your algorithm works for a month, but if you continue doing that way, so in 12 months, it's just stopped working. So another benefit of knowing the limits is just like write a simple test, multiply your data by a factor of 1,000 or million, whatever your load is, and see if it will continue to work. Because you could end up in a situation where, where you need to reproduce something or you need to create a plot, but you cannot because you need to refactor your code or optimize something. And basically, that's my journey through this data visualization horror movie. Now I feel myself a bit better knowing those things, but before it was not the case. The main messages are like work collaboratively with your partners, aim for reproducibility, and for me, the version control is the key. So I know that at any point of time I can reproduce any graph. Back up the data, version the code, set up monitoring, and create a continuous pipeline that can help you to identify the bugs and probably save you, not life, but save you lots of time in the long run. Thank you, and I'm open for questions.
Before we can go to questions, I would like to summarize again very briefly. Please pick up your wristbands for the social event at the registration desk as early as possible. Also, there is the lost and found desk if you have lost anything. Please pick up your PyLadies wristband if you are interested. Also, the next presentation, which would be held in this room, was shifted. So there's no presentation next in this room. Now we can get to the questions after I thank Artem for this great presentation. I think the drawings were so cool. If you have any questions, just write them down at Slido. Also, just vote the other questions up, please. First question. How do you test the graphics you generate? Is it manual, by eye, or do you have some method of automatic check?
Yeah, that's a great question. Actually, I write a test for my data visualization also because I found myself once, it's related to reproducibility. And if you remember from one slide, when I separate the data from data visualization, I had a line that says like pandas, read CSV, blah, blah, blah. So in one case, I draw a line plot where it was like accepting a column X and a column Y, but it accepted all the columns that starts with Y. My data changed over the time, and I created a very nasty plot with the same plotting function where I had like not one line on my plot, but tens of lines. So what I test that, okay, I know that this specific graph that I ship to my customers, it consists of 2 lines. And since everything in Python is an object, you can write a simple test saying that, okay, get the axis object and ensure that the number of lines is equal to 2. This is the basic test that I write every time now. Maybe there are other tests. We can just think what is your visualization and write the test to ensure that it's there.
Next question. Matplotlib versus Seaborn versus Altair?
Well, it's a very hard question for me. I love Matplotlib because it's like a tool that, I feel the most comfortable with. But any other tool is great, so it's just like, it's individual preferences. But it's also related to the domain because when I usually create the data visualization, I create them for reports. And those reports are usually static. They are printed on the paper. And in that scenario, Matplotlib is, it's a winner for me because I can tune any object on the Matplot.
There's time for just one more question. Question to the global warming example. When plotting temperature versus time, there is no obvious scale. So how do you decide what axis scaling is not misleading?
Yeah, actually, that's a good question. And in some books, there are some recommendations. But what I found myself doing is that experimenting with scale and trying to show and communicate with people and just showing them the graph and asking like what you can say looking into the graph. Because if you remember the bar chart example that I showed you that before had like 5 colors for each bar, and in the end like it was down to 1 selected bar. And I say that, okay, here the message is clear that author wanted to say something about bacon. And the same works for the data visualization, like with the line charts. So I could end up like with a few examples of the different axes, and then I'll just discuss with people with whom I work, like what you can say, like, which one would you prefer? Or in my own judgment, I could see that, hey, this is bad, this looks better. So maybe it's less biased.
Again, thank you for your great talk.
Thank you.